Hello friends, welcome to EC Academy. In this lecture, let us understand the properties of convolution sum. The first property is commutative property. The commutative property states that x of n star h of n will be equal to h of n star x of n. So it states that x of n convoluted with h of n should be equal to h of n convoluted with x of n. Now let us prove this property. First let us take LHS. X of n star h of n is equal to, so we can write the formula for convolution. So we can write that as summation of k is equal to minus infinity to infinity x of k into h of n minus k. Now let us put n minus k as m. So from this we can take k is equal to n minus m. Now if we take k is equal to minus infinity, if we put k is equal to minus infinity, m will be equal to infinity. And if we put k is equal to infinity, so if we put k is equal to infinity, at that case we will get m is equal to minus infinity. So using this we can write the above equation as x of n convoluted with h of n is equal to, in place of k we can write it as summation of m. So we can take that as summation of m is equal to infinity to minus infinity x of n minus m. So in place of k we are writing n minus m into h of m. So in place of n minus k we are writing m. So in place of n minus k we can write m. Now this summation can be written as, we can write this summation as summation of m is equal to minus infinity to infinity, because adding the terms from infinity to minus infinity will be same as adding the terms from minus infinity to infinity. So there will be no change. So that's why we can change this summation. We can write this as x of n minus m into h of m. So the above equation we can write this as summation of k is equal to minus infinity to infinity x of n minus k into h of k. So we are taking the term k instead of m and we have written this equation. So the above equation can be written as summation of k is equal to minus infinity to infinity h of k into x of n minus k. So we are just rearranging the terms and we are writing the equation as h of k into x of n minus k. So we can say x of n convoluted with h of n can be written as, so using the formula of convolution sum we can write this as h of n convoluted with x of n. So we have proved the first property, which is commutative property. Now let us consider the second property, which is associative property. So here we are taking three terms for convolution. In LHS, x1 of n convoluted with h1 of n, then it is convoluted with h2 of n. So in RHS, h1 of n is convoluted with h2 of n and then that is convoluted with x of n. So we need to prove LHS is equal to RHS. So for this let us take x of n convoluted with h1 of n as f1 of n and h1 of n convoluted with h2 of n as f2 of n. So what we are doing, we are taking this as f1 of n and we are taking this as f2 of n. So we can write, using the formula of convolution sum, we can write f1 of n is equal to summation of k is equal to minus infinity to infinity x of k into h1 of n minus k, and we can write f2 of n is equal to summation of k is equal to minus infinity to infinity h1 of k into h2 of n minus k. Now let us consider the LHS. So we can write that as x of n convoluted with h1 of n convoluted with h2 of n. We can write this as, since we have considered this term as f1 of n, we can write that as f1 of n convoluted with h2 of n. Now let us write this equation as summation m is equal to minus infinity to infinity f1 of n into h2 of n minus k. So this we have written from the formula of convolution sum. Now let us write this equation as summation of m is equal to minus infinity to infinity. We know f1 of n is equal to this equation. Let us put this equation. We can write this as summation of k is equal to minus infinity to infinity x of k into h1 of, so instead of n minus k we can write it as m minus k, since we have taken summation as m here. So m minus k into h2 of n minus m. Now let us rearrange the order of summation. Let us change the order of summation. We can write this as summation of k is equal to minus infinity to infinity x of k into summation of m is equal to minus infinity to infinity h1 of m minus k dot h2 of n minus m. Let us put m minus k is equal to r, which means from this we will get m is equal to k plus r. So let us replace m minus k as r. If m tends to infinity, then r will also tends to infinity, and if m tends to minus infinity, r will also change to minus infinity. Using this, we can write this equation as x of n star h1 of n star h2 of n is equal to, so we can write this equation as summation of k is equal to minus infinity to infinity x of k. So we'll retain this term as it is. For this term we'll write it as summation of, so instead of m we can write it as r. So r is equal to minus infinity to infinity h1 of r into h2 of n minus k minus r. So in this equation the value of m is replaced with k plus r. So here we will get n minus k minus r. Since f2 of n is equal to summation of r is equal to minus infinity to infinity h1 of r into h2 of n minus r, you can see both the equations are same. So instead of k we are having in this equation r, so both the equations are same. So we can write f2 of n minus k as summation of r is equal to minus infinity to infinity h1 of r into h2 of n minus k minus r. So using this equation, we can write the above equation as, x of n star h1 of n star h2 of n is equal to summation of k is equal to minus infinity to infinity x of k. So we can retain that term as it is. For the next term, we can write it as f2 of n minus k. So we are replacing this term with f2 of n minus k. So using the formula of convolution sum, we can write this equation as x of n convoluted with f2 of n. So we can write this equation as x of n star h1 of n star h2 of n is equal to, you can see x of n we can write as it is, star f2 of n is nothing but h1 of n star h2 of n. So we can write that as h1 of n star h2 of n. So we have proved the associative property for convolution.
The next property
sum
is a distributive property. The distributive property states that x of n convoluted with h1 of n plus h2 of n can be written as x of n convoluted with h1 of n plus x of n convoluted with h2 of n. So x of n convoluted with h1 of n plus h2 of n can be written as x of n convoluted with h1 of n plus x of n convoluted with h2 of n. Now let us prove this property. Now let us take LHS. Let us take x of n convoluted with h1 of n plus h2 of n. Let us use the formula for convolution sum, and we can write this as summation of k is equal to minus infinity to infinity x of k into h1 of n minus k plus h2 of n minus k. Now this RHS can be written as summation of k is equal to minus infinity to infinity x of k into h1 of n minus k plus summation of k is equal to minus infinity to infinity x of k into h2 of n minus k. So this part of the equation we can write it as x of n convoluted with h1 of n plus the second part of this equation we can write it as x of n convoluted with h2 of n. So we have proved x of n convoluted with h1 of n plus h2 of n can be written as x of n convoluted with h1 of n plus x of n convoluted with h2 of n. So the next property is identity sequence. The identity sequence for convolution sum can be written as delta of n. So which means if you take x of n convoluted with delta of n, it will be equal to x of n itself. So you convolute x of n, any sequence, with a delta of n, you will get the same sequence. So if you convolute any signal with delta of n, you will get the same signal. So this is nothing but the identity property of convolution sum. Now let us see the next property. The convolution of delayed unit impulse sequence can be given as x of n convoluted with delta of n minus k will be equal to x of n minus k. The next property is the convolution of two delayed unit impulse sequence delta of n minus k convoluted with delta of n minus m can be written as delta of n minus m plus k. So this is one of the important property. So if you are taking two delayed unit impulse sequence, at that case you will get delta of n minus m plus k. So this is about the properties of convolution sum. Hope you have understood the topic. Thank you.